Welcome, I'm Kevin King. In this, the third of our series of 6 training videos, I will introduce how to set up a new machine and do the initial field runs. Other videos in this series take you all the way from how our systems work through to creating configuration files for crop or machine geometries that you've not already got stored preset configurations for. You can select the video you need from our website and view it as many times as you want. The same material is covered in rather more detail in our reference manuals, which can be also downloaded from our website. The Interrow reference manual is available in English, French, Spanish, Polish and German languages. So let's get started. First, you need to mount the components onto the implement and tractor. Pay particular attention to ensuring that the camera is mounted rigidly onto the frame, with provision for height and inclination adjustment. Whilst not essential, it is much simpler if the camera pole is arranged to be square to the frame, so that the pole is vertical when the implement is horizontal. For consoles, we recommend ram mounts as they are easy to use and provide a degree of vibration isolation. Check that any sensors fitted trigger with the appropriate movement, especially lift sensors, which can, if not fitted correctly, produce spurious lift signals, potentially interrupting vision guidance as wheel ruts are traversed. If this is difficult to achieve, consider an alternative mounting position or possibly use the tractor's 7-pin ISO 11786 socket or an isobus connection to provide lift and speed signals. Visual odometry is a useful alternative speed input if a reliable odometer signal cannot be achieved. Our cables come in varying lengths, so it should always be possible to specify cable runs that avoid trip points or coils of excess cable. Connect both 12-volt power and hydraulics. Press and hold on the power up button until it is illuminated and wait for the home screen to appear. From the home screen, navigate to the setup screen via the working screen. On the first line, select the appropriate configuration. Return to the working screen. Lift the implement, checking that the lift symbol appears on screen. When it is safe to do so and all personnel are clear of the implement, adjust the hydraulic supply flow from your tractor if possible. Set this to a low flow setting to avoid excessive oil flow and heat. Turn on your hydraulic supply flow and set it to a constant flow setting. If you lower and then raise the implement, it should automatically centralise the side shift or steering discs. If it does not return to central position following this lower and lift procedure, then you may need to perform a steering test to calibrate steering orientation. To access the steering test from the working screen, press the spanner button and then the spanner ++ button. To perform a steering test, check that the hydraulic supply hoses are connected to the tractor. Check all personnel are clear of the implement and that sufficient clearance is available for the machine to exercise the steering fully. If hydraulic flow from the tractor can be adjusted, reduce flow to a suitable level as excessive oil flow can cause heat or potentially return a too fast response from the steering test. Typically, hydraulic flows of 5 to 10% can be sufficient for steering operation. Turn on hydraulic flow to the implement, ensuring direction of flow is correct. The implement should be in the out of work lifted position in order for the steering test to operate. Run the steering test application and respond to the on-screen prompts. Responses to these prompts are used for calibrating orientation of the steering. Left and right orientation are defined as looking forward in the direction of travel. If the test is successful, an OK message will be returned. If not, a fault message will be returned and can be responded to accordingly. Too fast. You need to reduce oil flow rate to the cylinder or reduce the supply oil flow. If you get a too slow, increase the oil flow to the cylinder or increase the supply oil flow. If it says hit stop, check that the position sensor is central and mounted correctly. Also check if its stroke matches that of the steering device. You can also exercise side shift or steering discs by entering manual mode from the working screen and pressing the left or right arrow keys. Each time you press an arrow key, the side shift will move 7% of its stroke. If you keep pressing the same key in quick succession, you get a continuous movement. A typical steering rate for a side shift should be approximately 10 cm per second. Now let's consider the same procedure for the proportional valve. The test is entered in exactly the same way. The system should already know that a proportional valve is fitted. It will therefore automatically follow the appropriate procedure. The proportional valve steering test starts in the same way and again will require you to confirm direction of travel. However, having established the correct direction of travel, the system will automatically go on to make additional full-stroke movements to calibrate speed. Like the non-proportional steering test, you may be given warnings which might have slightly different implications for a system fitted with proportional valves. For example, too slow might indicate that the valve does not have the flow capacity to drive the cylinder at the required rate. Once the steering test has returned an OK message, steering orientation and calibration has been saved. An optional purge function can be enabled to purge the hydraulic circuit and cylinders from air, using timed left and right outputs to end stops or to register and synchronize left and right steering cylinders if required. We are going to cover 3 ways of setting cameras up. The one covered on this slide is done purely by measurement with a suitable configuration preloaded and does not necessarily require you to be in the field, so is useful at the factory. The second is another measurement technique, but when the configuration loaded is not quite suitable, or there are some constraints to camera mounting geometry. The third allows you to visually match the crop in the field to the computer's template. All 3 should yield the same result. It is best to reset any spurious or previously learnt camera height or look-ahead parameters from the Learn Parameters page. It may be beneficial to turn off Auto Learn for initial camera setup to avoid spurious auto adjustment of height and look-ahead when no crop rows are present. From the setup screen, ensure that you have selected the appropriate configuration for your machine and its intended crop. Make a note of the camera height and look ahead from the figures displayed at the bottom left of that screen. Note that these parameters can also be viewed from the Learned Camera Parameters page. Physically adjust the camera height on the pole to match that figure. Remember that height is measured from soil level, so you might have to make some allowance for that if sat on a concrete factory floor. For best accuracy, camera measurements should be made to the centre of the lens, which is about level with the back of the camera turret. Next, place a marker on the ground immediately underneath the camera. Measure forwards from that marker by the look-ahead distance and place another marker on the ground. A spanner is our traditional marker of choice. Set the console working screen to manual mode. You should see that the blue crosshairs have been superimposed over the live video image. Adjust camera inclination angle until the centre of these crosshairs coincides with the look-ahead marker. Once you have aligned the blue crosshairs and the placed marker, you can then tighten the screws. The camera is now set up. You will have to repeat that for any other cameras fitted. Remember to turn on Auto Learn when heading to the field so that you can make use of the automatic camera height and look-ahead adjustment feature. If we are unable to achieve the height and look-ahead parameters to suit the existing configuration, we will have to perform an alternative measurement technique of camera setup in reverse compared to the previous method. This could be due to tractor or implement frame impeding the camera view, and camera position will need to be adjusted to compensate. First step will be to manipulate the camera into place to achieve the desired or required view. Measure the camera height and note this down. We will need to enter this into the configuration file. Next, place a marker on the ground immediately under the camera. Enter the working screen and select manual mode. This will bring up the blue centre crosshairs. Place a marker on the ground aligned with the horizontal blue crosshair. Measure the distance between the two markers. This is our new look ahead value. Make a note of this value ready for entering into the configuration file. If there are any other cameras mounted that require this type of setup, repeat the above procedure, making note of the relevant parameters. Open the configuration editor and either modify an existing configuration to suit the new camera parameters, or copy and edit the existing configuration to incorporate the new measured camera parameters. We will cover configuration editor use in video 6. Name this configuration in such a way that the user will recognize it. Now going back to a situation where we already have a good configuration and just need to set the camera up. If we are in a field with an emerged crop, this gives us another equally valid option for setting cameras up to match preset values. As before, we need to open the setup page to check that we have the appropriate configuration selected and that the crop height setting matches the crop that we are in. But this time we only need to make a note of the camera height. Set the machine into the field so that it is at its normal working level with the camera pole vertical. Position the camera over or between the appropriate rows to be tracked. Adjust the camera height to be approximately the same as the value in the selected configuration. If you return the console to the working page and set the guidance system to manual mode, this will lock the template in place ready for camera setup. If the template appears skewed at an angle, this is due to there being a crude camera skew. This should be reset from the Learned Camera Parameter screen in order to proceed with setting up the camera geometry. If the template appears to be offset, this can indicate that the fine offset is non-central and should be reset to central position, bringing the template back to center. For a single camera implement or the left-hand camera 0, adjusting the fine offset to center will always bring the template back to center, as shown here. In the case of additional cameras, an offset camera template would indicate that the offset has been accrued, and should be reset via the Learned Camera Parameter screen to bring the template back to center. Ensuring the guidance system remains in manual mode, compare the actual crop rows with the virtual template green lines. First, we will consider the lateral positioning of the camera. If the template is centered to the camera view, but the crop rows are not aligned, slide the camera laterally along the implement to align the crop rows and template lines. Repeat this lateral alignment for any other cameras on the implement. Once all cameras are laterally aligned, we can then consider the camera angle adjustment. If your crop is quite small, the rows may be quite difficult to view. Full screen mode may make smaller crop rows easier to identify. It is also possible to place markers on the ground, in this case spanners, to identify where the crop rows are, for comparison with the template. If your template matches the crop rows fully from top of the camera view to the bottom of the camera view, your template match should look like this. However, if it looks like this, it will be worth making some adjustment to improve the fit in order to achieve better performance. There are 3 solutions to improving the template match. The first and the simplest method being to turn on Auto Learn and use a short press of the Auto button for guidance to re-evaluate template match with the actual crop rows and automatically adjust camera look ahead when in the working mode. Alternatively, in the case shown, it is possible to physically point the camera upwards to a more shallow angle until you get the desired alignment of the template to crop rows. Or if the above is not possible and you cannot move the camera far enough to get the desired alignment, you might need to make a note of the camera height and look ahead that you can achieve and create a new configuration based on those parameters. Information on how to adjust your camera setup parameters is available in our other videos and reference manuals. This is a similar situation, but the other way around. Our 3 possible solutions to this being use of the Auto Learn feature, our recommended course of action for most applications, mechanical adjustment of the camera angle, in this case it looks like you should point the camera downwards to a steeper angle until you achieve alignment. Hopefully the above methods are possible, but again, if not, you can make a note of the camera height and look ahead that you can achieve and create a new configuration with those parameters. Hopefully we now have a view that looks like this. However, as we only set camera height approximately, and if the view looks something like this, it may be that the camera height also needs adjusting. In this case, the camera looks to be too low. Before we move the camera up, there are another couple parameters that might need double checking. First, check that the crop size setting selected on the setup page is appropriate to the crop in view. If not, change the selection and try again. If you still do not have a good match, check that the row spacing you have in the field matches the figure displayed at the bottom of the setup screen. If not, you should either select a configuration with the correct row spacing, or if you do not have one, create a new one. Contact your dealer on how to do this or consult our other training videos or reference manuals. If the difference between actual row spacing and the configuration value is small, it is possible to fool the system by simply moving the camera up or down until the template lines are in alignment with the crop. In most situations this will work. However, there are two reasons why you may want to get the figures right. First is that it may cause confusion with future users and technicians who were not aware of the history. Second, that if the machine is obtaining speed using our visual odometry, it will give an incorrect figure if the geometry is not the same as those used for its calculations. If the difference is small, the speed error will also be small. In this case, it looks like we need to move the camera down for a good template match. Though as we have just discussed, it might be worth checking crop size and row spacing figure to check that they have been correctly set. If there is still some degree of misalignment, this can be solved by moving the camera vertically down the camera pole, or by turning on auto learn, and this minor difference in height can be automatically compensated for, this being the preferred method of adjustment. So whatever your setup and whatever the procedure you used, when all is done, remember to tighten the bolts. If you go into vision guidance mode by pressing the hand to camera button, all the green template lines should align perfectly with the real crop rows, and there should be a line of blue crosses vertically up the centre of the image. If you have multiple cameras, you will need to repeat this for all cameras, but otherwise you're ready to go. Remember, not all cameras have to be set the same. You might set up cameras differently on the same machine for a variety of reasons. So hopefully, you'll end up with a template match that looks like this one. Accurate template matches makes a big difference to reliability, especially when conditions get difficult, so it's worth spending time to get this right. Now you know your steering is working correctly and that you have a good template match, it's time to get running in the field. First, it is worth making a few basic mechanical checks. For example, that the hoe blades are accurately spaced between rows. A final check that the steering is working. This could simply be using the manual button to check that the side shift is moving smoothly and in the correct direction when in the lifted position. Ensure the top link is set correctly and that the implement is level. Changing the length of the top link to adjust cultivation depth should not be carried out, as this can change camera geometry, potentially leading to reduced camera guidance performance. If changes to camera geometry occur in this way, use the Auto Learn feature to compensate for these changes by selecting a camera and pressing the Auto button to re-evaluate and learn the new camera parameters. Depending on your confidence levels and the value of your test crop, you may wish to remove or raise blades out of the soil to minimise any crop damage during the initial learning phase. Align the implement with the crop rows as you lower it into the crop. Do one final check for template match. If it is good, set off slowly. Vision guidance will start immediately. However, for the first 100 meters or so, it is learning the camera skew angle, and for multiple cameras, it is also learning camera offset. For this to work at its best, crop rows need to be clear and dominant, and the field should be relatively flat. Weeds can be present but should not be overly dominant at this stage of initial setup. If possible, avoid side slopes during initial running and setup. You may find that you have to adjust fine offset as camera skew and offset parameters are learned. Fine offset can be applied while the machine is working. After 100 meters or less, camera skew should have stabilized. It should settle at a value of less than 3 degrees. Fine offset will probably not be central, so it is good practice to centralize that by moving the camera laterally by 1 cm per tick of offset. Working out the direction is the challenge. You could try thinking of the camera as locked over rows and moving the machine to compensate for any error. So for example, if a machine runs to the left, requiring 3 ticks of fine offset to the right to compensate, then the camera should be moved to the left by 3 cm to neutralise this applied fine offset. Having done that, the machine is now set up for accurate inter-row cultivation. Just one final point, unless camera orientation in the yaw plane is changed, skew should not routinely be reset to 0. After every reset, a further learning run on an easy crop is required before full performance is restored. We hope that you have found this presentation useful. Remember that it is part of a series of 6 videos that you can select from our website and view them as many times as you want. Our website also has links to other reference and training material, including full reference manuals in a variety of languages. If you have any questions, please get in touch. Thanks for watching.